Well, welcome everyone, and welcome to yet another episode on this Autograd series from scratch. So we were just building our Autograd computational graph, and we are just verifying if our graph works fine. And we have completed a couple of layers like multi-head attention and layer norm. And in case if I run this script right here, so you can have an idea that what's going on. So we have visited 91 nodes, and these are the tensor nodes basically, and the operation nodes from multi-head attention and layer norm. So what does this mean? That in our computational graph we have lots of different nodes, and the nodes means we have tensor, we have some operations that are creating those tensors and everything. So we've been able to successfully traverse all these nodes, all those tensors that we are generating. But there's a problem. So the problem is, right now you see we have, for example, let's consider this particular node. So if it has, it says that it has had ID 23063, it requires grade equals 1, and it has parents 1, and it has some operations or some backward function pointer at this address, and this is actually the gradient pointer on this particular address, right? So far till these two tensors we are very good, right? So we are able to traverse backwards. But you see, as soon as this op nil comes in, right, and this grade nil comes in, our graph tends to break, because we are just I'm just like you can say printing these nodes over here, but I'm trying to actually visualize this graph, that which tensors, which particular node is created where, right? So I'm trying to do this, and this actually is causing me the problems. And how it's causing me the problems, let me just show you. So I'm trying to give it a more visual look, right, so that you can actually see the nodes, the edges, the graphs and everything. So I can also just quickly verify from this visualization that okay, this we are good till here, right? So the problem that I'm trying to face is here is, if I go here on this particular method, which is right here, and in case it just prints us like node ID requires grade parents and operations, and this is you see it's printing us a pointer, right? We don't want this pointer, we want actual function, that how this particular tensor was created. So in case if I just replaces this with, like, you can say with some string, and instead of printing operations I print like, let's say, name of the operations, right? And if I do this, and let's see what can I have now. So yeah, so you see we're able to print these three tensors, 261, 65 and 63. So we have operation names also available. These are actually the nodes, but the error comes here when grade equals null. So when requires grade equals 1 and grade is actually equals null, we tend to break the graph, right? So we were printing so this is actually good. We were printing the names of the operations. So this particular tensor having ID 267 was created with addition operation. When two tensors got added, this was created right here, and it requires grade obviously, and it has two parents. That makes sense. Operation scaled. Scale is basically a square of two tensor, like element wise a square. So I should change this name, but it's basically element wise multiplication of two tensors. So it has also two parents. It has tensor ID is this. It requires grade. Makes sense. Expand rows. Expand rows means like you are expanding row wise, because sometimes you have only one row, and you just, in order to make the shape equivalent, you just tend to expand the rows in order to make the shape equivalent with the next tensor which you're applying, making some operation with. So this also requires grade. But the problem is here, as soon as the error comes and the grade is null, so we tend to break this graph, and which is like actually the problem here. So let's just go back here and see what's wrong, right? And let's just try to overcome this somehow. So in case if I say constant character, constant character, let's say name, and this should not be a pointer, so name equals root operations type when root, can I just do this? Yeah, root operations root operations and root operations name, otherwise just give us null. And I don't think this should work either, but I mean, let me just try to do this. So let's just call it name maybe, yeah, and maybe op name, and this is op name. So let's just try to see if it works. And yeah, so hint address points to 0 page. Root operations, and it prints like I think it still doesn't work. Type, can I print the type? Let's just try to print the type, which is an enum, and there's something wrong. Okay, so just let's see what's wrong now. Still we cannot get it, so we're printing the type successfully, but something is wrong, and root operations, and let's just give it name, because this works fine for us. And if I go like this, okay, so we need to like do something whenever the requires grid equals 1 but grid equals null, we have this problem, right? So we need to see in our tensor library that which actually is the method where we have actually tried to calculate the output tensor from some tensor operation, and we haven't set some required stuff, right? And if I go here, and now what do we mean by that? So you see we have requires grid equals 1 but grid equals null. So we want to see that where we have requires grid equals 1 in the output tensor, and we haven't set the set the grid, right? So in case if I go here, I say requires grid equals true, right? Here we have set the gradient, and like, will it be null or what? If we do something like this, will it be null? It won't be null. It won't be null. Okay. Requires squared equals true. Requires squared equals true, and arena allocate. Ooh, what is this? No, this is wrong. So we can say tensor create new, and this would be arena and dimension and out shape. right? That's how we actually create a tensor. And let's just try to see. And what method did we just change? So out requires grad. Yeah, exp, this was the one actually, but it has only one parent. Okay, this is fine. This is fine. So we are creating the grad tensor over here. This should not be null. And yeah, this is also good. Scaling, what's wrong here? Tensor create new. Tensor create new. Okay. And we have tensor create new. Requires grad equals true and woo. Have I found it? Have I found it? Which method is this one? So tensor matimal. Oh man. Alright, so whenever we have requires grad equals 0, operations becomes null, which is obvious, and grad is also null, right? So that means that this should be a leaf tensor. First thing, this is not coming from any node, operation node. This should be a leaf tensor, right? And in case if I see how many leaf tensors do I have, then we can have an idea that. So the problem is we haven't set this logic for leaf tensors. We haven't set no operations for the leaf tensors, and that's why we're having issues. It's breaking the graph. Whenever we try to print the name of the operation, there's no name given because the operation is basically a leaf tensor, which is not coming from any operation. It's a standalone tensor, right? And now I want to trace out that which exact are the methods where actually the operation is, the tensor is leaf tensor. So first of all, let me just try to see this file called this function called tensor. So in case if I just so we have this tensor file, and I'm gonna look for a specific tensor function called tensor create new. And you see it just creates a tensor. It does not have any leaves, right? And for now the number of parents equals 0 and requires grad equals false, right? And if I run this, I can see that this is actually the tensor where parents equals 0, and now the operations are null here. Tensor create new. So the operations are null. I haven't said, yeah, the operations are null. So can I set a type here? If operations is null, can I do something like this? I mean, this is going to be a stupid idea, but what's wrong with trying, right? Type equals leaf and t t operations name equals op leaf, like leaf tensor. Can I do something like this? Well, I don't think if I can do something like this. Right, because I'm already setting the operations equals null, and I don't know if that would make sense. Yeah, so tensor dot edge and just add a leaf here in the end. So this is going to be leaf. Ooh, let's see what happens. It's not even printing anything in the first place. Tensor validate, and now instead of using this one, so let's try to use this one. Oh no way, this is not gonna work. This is not gonna work. This is stupid. Huh. Fundamental programming flaw. Tensor create new, and I'm gonna just chain this thing. Okay, can I do something like this? Alright, so I think it's working for now. In case if I check this method right here. Still not working. So I think there's something wrong when we have a leaf tensor, right? Which has gradient equals null, and let's just tensor C, and in case we have validate tensor, and invalidate tensor, if we try to print the name and name. Visited node only one. Okay, so if we like check this function, if we like check for attention layer only, let's see if this works. Ellen, let's just comment this thing out. Let's see if our multi-head attention layer works or not. So we've made a couple of changes over here. First of all, we set the memset 0. for the newly initiated tensors. So that actually sets the memory equals 0, so we don't stumble upon garbage memory problems. And another thing that I did is I'm trying to print the type of the tensor in case if operation is not null and type is not null, right? So both of them are not null, we can have the type available, right? And if I come over here and uncomment this entire thing, yeah, inside, let's just try to run it now. So we have only one visited node. Okay, so it's trying to print something. Validate. Name. There it is. Operations and operations name. Put operations names, otherwise no. Should work. Only one visited node. Why is it breaking? Why is it breaking after the first operation? This should not break. It's not even traversing it at the first place. Validate. Memset and memset. What is wrong? It should work now. Validate. Should work now, like seriously. It's annoying. This is annoying me. This is pissing me off, like seriously. Will this work? It's not even traversing the graph. Oh, I mean, did I make some mistake over here? so now what we want to do is I just want to come over here and look for the function validate, and inside here, instead of printing these, what we want to do is we don't want to print pointer, and instead what do I want to do is root. I want to check root operations and root operations name, and then print what on root operations name, else print null. Something is wrong. What's wrong? So operations validate. Okay, so so it looks like we are able to get the names of the operations. Okay, so whenever the tensor is like doesn't require any gradient and it has parent 0, the operation is going to be null, because we can say that it's a leaf tensor. And if the tensor is derived from some operation, then we can just put the name of the operation over here. And you see, we have all the names available, I mean, which is great. It looks like now we are actually moving towards the this is something we needed basically, because so whenever the required squared equals 0, parents are not found, no parents, then it's going to be null, and which is, we can say that it's a leaf tensor. So we can also do one cool thing, which gives much more meaning to this. Instead of like typing validate, so instead of like printing null, what we can do is we can just print leaf, so that makes much more sense, right? Doesn't it? Okay, so we have a leaf, right? This is great. I mean, this is wonderful. So now we can get the names of these operations, and next we will be like doing something that actually creates a visual graph for us, which we can see, and we can just have an idea that what's going on underneath with our graph, right? So let me just push these changes. Git commit graph fixed graph. Git push origin validator. Oh, looks like we don't have internet connection for now. I will push, or let me just connect once. So funny, I was not even connected with the internet. I mean, that's cool. That shows you my ability, that how real programmer I am. I don't take any consultees from internet. So git add dash git commit dash m fixed graph related issues, and git push origin graph validator. Very cool. One last thing that we want to test over here is just connect these two layers, layer norm and multi-area extension, and see if everything still works. So I'm just gonna come over here, ln.c, put it right here, and just go to ettn and main do this, come here, come here, come here. Oh yeah. Okay, and let's just first see if layer norm is still working. So we have this out, and I'm not gonna test initially this for out. What I'm gonna do instead is I'm gonna test it for this right here, right? This should be X. Let's see what happens. Very cool. We found 15 nodes and the names as well. I mean, this is great. Requires grade 1, null. 0 requires grade 1, but grade equals null. And rec 0, parent 0. Okay, something's wrong here. We'll check that. Null grade. Okay. And now, the most important part. If I just connect it with the output of multi-head attention, let's see what happens then. Excited? Well, I am. Great. So we found 91 visited node, 1 null gradient equals true, which is coming from layer node. We'll see if it's like the initial tensor or what. And oh, we can also just quickly verify this. Where exactly this tensor is coming from, which requires red. Yeah. Should not set this. Now this might resolve. Oh, it's still there. So we'll have to check this. We don't want to explicitly set the grade equals true. And okay, so we ran here multi-head attention, and then right now we have 91 nodes, right? 91 operations. Each one of them is associated with some name, has some name actually, which gives a sense of how this tensor was created. And now all we have to do is to convert this to a visual graph, and that's it. Get commit dash m. Validator. Okay, this was it, and I will see you in the next one. Take care. Bye bye.